G'day guys. As you can probably see from looking at my bench, and power supply and just the way things are hooked up at the moment, I've been messing around with the panel meter again. Just to go over this quickly, this is the negative sense, also the lead the panel meter gets its power from, going to the emitter of the comparator transistor in the power supply. And if we just take a look at the scope, if I disconnect it, you see it gets a little bit quieter. A little bit of that noise goes away. If I connect it, a bit of high frequency stuff comes back. But the problem is, that's only small. I don't like it, but it's only small. When I go to remote sense, which is putting 10 ohms of resistance between these two terminals, look what the panel meter does. It breaks out into full oscillation and sticks it right back in the supply. So, when I first saw this, silly me, I actually just thought that the panel meter was just leaking like some half wave rectified ripple. Sorry, full wave rectified, like 100 hertz DC ripple, like coming in off of the 12 volt rail that I was powering it off of, or am powering it off of. And you know, that was coming back out and into my circuit. I didn't actually consider that the meter itself was producing any kind of noise. I just thought it was leaking noise through itself, if that makes sense. Out of one wire, in one wire and out the other, so to speak. So the solution I came up with was an op-amp buffer. It seemed like it was going to work out for me in terms of removing the noise, but I noticed something today. When I had the op-amp on a breadboard, first I had the breadboard mounted here at the front of the case with a couple of banana leads that have got some length, so obviously some resistance and some inductance to them, and some capacitance. I had those powering the op-amp from the 12 volt rail here, and the ground starting point here. And I had my panel meter's negative source and the panel meter's negative sense, you know, going in and out of the op-amp, and I had it all here, the voltage follower that I had over here in previous videos. Anyway, didn't work at all. The meter was reading all zeros until I turned the voltage up to a volt or two, and then it broke out into full oscillation. And when I say full oscillation, I mean the supply voltage coming out of the voltage follower was jumping up and down by 2 to 4 volts. I didn't even put the scope on it. I just stuck my multimeter on it and saw the voltage fluctuating everywhere and knew straight away like it's broken out into crazy oscillation. So I thought, surely it's just, you know, high impedance input network on that, long wires, something like that. So I did all the usual things, tried decoupling stuff, adding input resistors, capacitors, to decouple the inputs, you know, power supply, rail caps. It made everything, all the leads shorter until I was down to this. It was still there. It finally hit me. The panel meter is actually oscillating itself. And you know what? If I actually just, this is going to be really janky. I don't know if I should do this. Let's go for it. If we go bang, oh well. Okay, the op amp has power. Okay, that's the output of the op amp. That's the input. We'll take our panel meter, we'll connect it to our output. Trying to do this with one hand without dropping any connections and shorting stuff out in the power supply is insanely hard. I'm taking a big risk here to show you guys this. Get that. Ooh. Got it. Right. Oh. Whoops. I was like, what the hell? It's not oscillating. Right, there we go. It's oscillating. Now, at first I thought the sound was coming out of the actual 7812 regulator. I thought it was oscillating back to this and the heatsink was resonating, or possibly the buzz bar piece of copper wire going to the heatsink. So like I still hadn't realised my panel meter was oscillating. Anyway, I stuck my ear in here and I realised the sound was coming from the panel meter. I'm just going to put the phone microphone up to it. I don't know if you guys will be able to hear this. Maybe we'll try in the back of it. I don't know if anyone could hear that high-pitched sound, ringing, oscillating sound. We'll disconnect this because that's not good for the op amp. But this panel meter has some sort of oscillation going on its power supply, on its regulator, on its input. So, sorry. More work has to be done to the panel meter. This is just ridiculous. So, I've got one of the other ones over here. Give you guys a quick look at what's in it. We've got a Schottky diode on the input with a resistor going into it. Looks like 150 ohms. Yeah, 150 I think. 150 ohms going to a little Schottky diode. I think it's a Schottky. Going into the regulator, coming out to a little ceramic capacitor, and then that trace, I should probably point to you guys, that's the resistor I'm talking about. Power's going through that, through the diode, into the regulator, coming out, being filled to ground, and it's going off over here and powering things. So I'm going to have to have a look over, sorry. Oh, was that out of focus? Man, I've got really bad hands when it comes to holding a camera. The line in question was this resistor, this diode, going into this regulator, and this capacitor on the output coming out over here. So anyway, I'm going to have a look into that circuit and see what it's doing, and then fix it. But yeah, I don't know if it's like you use it with long wires or too high or even impedance on the input or some for the voltage supply to it, or what it is that causes this condition. But obviously it wasn't designed to work in different environments very well. If it just breaks out into oscillation in such a clean and simple circuit like this. I mean, seriously, I've got wires hanging out the case, leads hooked up everywhere, bringing noise in, and we're still only at 85 to 90 microvolts. Yeah, just ridiculous. Everything in this power supply is all quiet. I know, because I built every single board and part in here myself by hand, and obviously tested everything as I went along the way. Not only as I built things and then tested them by powering them up and loading them, but also after everything's been added together, I've then retested points and discovered problems along the way and fixed those problems. Nothing ever is perfect the first time, especially when you design it from scratch. But anyway, I just wanted to update you guys on what's going on, because I was going to do a video tonight where I finished off the voltage follower to power this meter, and it turns out I might not need to. I might just need to fix the meter so it's not oscillating. So we'll see. That's all I've really got to say on that. So I'll leave it there, but definitely a video coming soon. I'm going to have to power one of these guys up on the bench and get my scope and scope along various points and see where the noise is coming from and see what I can do to get rid of it, and then I'll make a video on me doing that, because I've got 3 of these, so I've obviously got to do it to all 3 of them. So I'll work out what's wrong with one of them, and then I'll do a video of me doing the other 2, or at least one of them, so you guys get to see that problem being fixed too. But yeah, suffice it to say that so far the most annoying stuff in designing this has actually been fixing someone else's work, not my own. Who would have thought? That's all for now. See you soon, guys.